In this video, I will just talk about some of these, maybe all of this. Let's see how it goes. Some of these functions and how to find the minimum, maximum points here. It takes a lot of time, so I will not show all the calculation, but start with number 2 here. Here we have the function f of x is equals to minus 2x3 to the power of 3 plus 6x squared. If I want to find a minimum, maximum point, I have to find the derivative, move 3 down here to get minus 2 times 3, which is minus 6 squared. Move 2 down times 6 is 12x. So this is the derivative, and I should then put this equals to 0. And then I get a second degree equation here. So I must find out when this is 0. And to solve this equation, it's just 2 terms, right? So I don't have to use the ABC formula. Here I could just factorize. I have a lot of common, I have 6 in common. This is 6 times 2, and I have an x in common. And if the second degree term, the first term here, is negative, we also put minus outside. And then I have 1x left in this term. And in this term, this is 2 times 6. 6 is outside, x is outside. So here we have 2, number 2 left. And remember, if I put minus outside the brackets, I need to change sign inside. So I get this thing here. And then I see that we have a product here. 3 factors, this times this times this should be equals to 0. Then either x should be 0 or x should be equals to 2. So this means, again, we have 2 stationary points, 2 points, which is either a maximum point, a minimum point, or a terrace point, 3 rollerblade points, right? And then I have to find out which kind of point each of these is, and then I have to factorize. I have to draw the sign line, but first I have to factorize the derivative. I have done this here, and I then put up all 3 factors like this, right? And the first factor is minus 6, that's always negative. X is 0 and x is 0, then positive. And this, of course, is like this. And then I'll just multiply this together, and I get this. So just do this quickly, and then I see that it decreases, increases, and decreases. So that's the minimum point, and that is a maximum point. And then I have to find the y-coordinate, right? I don't show that. Let's just see the last video for that. And then the same with exercise 3 here. We have to find the derivative, and if I find the derivative here, I get 3x squared minus 6x if I differentiate this, and that should be equals to 0. And again, we don't need this ABC formula. We can just factorize like this, and we see that x must either be 0 or x has to be 2. So we have again 2 points like this, and then we need to draw sign lines like this, right? 3x, x minus 2, and so on, blah, 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 blah. And I will find out if this is max, min, or terrace, and the same with this. And then I find the y-coordinate. Okay. Same with exercise 4. I feel that the thing people are struggling with here is actually just solving the second degree equation in a correct way and drawing sign lines, factorizing in a correct way. That's often where it goes wrong, right? So number 4 as well, we have to find the derivative of this, which is minus 3x squared. Put 2 down, so I get plus 12x, and minus 9x is minus 9, 0. This one just disappears. This is the derivative, and I put this equals to 0. I get a second degree equation. Here we have 3 terms. I could use the ABC formula. I could do a trick as well. I could factorize. I have 3 in common in each term. Since this is negative, it's minus 3 outside, and I have x squared left here. Here we have 3 times 4. So I just have 4x left here. This is 3 times 3, so I have 3 left here. And remember, if I put minus outside the bracket, I have to change sign here. So it's minus here and plus here. Just multiply in to see that this is correct. Equals to 0, like that. Then I could, of course, just use the ABC formula at once here. A is minus 3, B is 12, and C is minus 9. But if I factorize out here, I get the product, which should be equals to 0. This is not 0, but this could be 0. And this is an easier equation to solve with the ABC formula, or even the shortcut. The product should be equals to 3, and the sum should be equal to this, but opposite sign, which is 4. and we then see then 1 and 3 is the solution. So we get x equals to 1 and x equals to 3. Right? So here we have stationary points, rollerblade points here, and then we draw the sign line, and then we need to factorize this one. This is the derivative, right? We have to factorize the derivative, so it's minus 3, and to factorize this is x minus 1 solution, which is 1, times x minus the other solution, which is 3. And then we draw sign lines, and we find out which is which, and then we find the y coordinate. I don't show all of it here. Just give you some help. Same with exercise 5. If you find the derivative here, we get 3x squared minus 12. That's the derivative equals to 0. Again, a second degree equation. Different ways of solving this. We could factorize, but I prefer to, since we don't have any x here, just x squared. I get x squared by itself by moving 12 over like this, dividing by 3, and I get x squared is equals to 4. And if x squared is equals to 4, then x is equals to plus minus square root of 4, which is plus minus 2. So remember, it could also be minus 2 here. 50% of the Norwegian population would just say x equals to 2. But it's plus 2 and minus 2, so we get two solutions here, x is 2 and x is minus 2. So again, we have two stationary points, two rollerblade points here. Which is which? We have to draw a sign line. So we have to draw the sign line of the derivative again. If I want to draw the sign line, I have to factorize. I need to factorize this thing. We have 3 in common, we see here. This is 4 times 3. Then I have x squared left here, and I have 4 left there. And I can continue to factorize. X squared minus 2 squared is x plus 2 times x minus 2. So then I have factorized it, and then I can draw sign line like this, and so on, and find the y coordinate. Do the rest yourself here. Same with exercise 6, the last one here. I need to find the derivative. I keep the constant 2 over 3 here, move 3 down like this, then x to the power of 2 I will get here, move 2 down, get 2x, 3 disappears. Here I can shorten this, so the derivative g of x actually here will be 2x squared plus 2x, like that. Okay, and then I just put this equals to 0, and here I can factorize again, 2x in common, and I have 1x left there, plus nothing left there. Remember, then put 1 here, so I get two solutions here, x is equals to 0 and x is equals to minus 1. So we have again two rollerblade points. To find out which is which, we have to draw the sign line of the derivative, which is this. We have to factorize it, which I have done, and I prefer to put it up like this. Think of it as 3 factors: 2, x plus 1. 2 is always positive, x is 0 here, and negative, positive, this is 0 when x is minus 1, and so on, and so on, and so on. So that was just to give you some help of exercise 2 to 6.